When students add and subtract decimals, they sometimes struggle with understanding the relative sizes of different place values, and they sometimes have difficulties carrying out the operations. To support student learning, the What Works Clearinghouse Practice Guide on assisting students struggling with mathematics recommends using concrete representations like these base 10 blocks and connecting them to abstract representations such as this expanded notation. In this video, we'll show an example of how you can use base 10 blocks to solve a decimal addition problem. One great thing about these blocks is that they're proportional. Because we're working with decimals, this orange flat piece will represent one whole, and 10 of these blue rods makes one whole. So that means one rod represents 1/10. 100 of these small cubes will make one whole, so one small cube is 1/100th. These proportional relationships between the base 10 blocks make it possible for students to regroup by trading pieces, such as trading 10 hundredths, or 10 small cubes, for 1/10, or one rod. Being able to regroup is important for adding and subtracting, and something that is often challenging for students. Okay, so here we have our problem. 2 64 hundredths plus 53 hundredths. And we'll use 3 columns to show the place values we'll be working with: hundredths, tenths, and ones. Let's use base 10 blocks to build the first addend, which is 2 64 hundredths. Since each one of these flats represents 1, I'll put out 2 of them. Then we need to represent the rest of the quantity, 64 hundredths. So we could pile 64 hundredths in the hundredths place, but we could also use tenths, because 60 hundredths is equal to 6 tenths. So I'll put 6 tenths in the tenths column. And finally, 4 small cubes here in the hundredths column to represent 4 hundredths. Now I'll label each of the values, so we connect the numbers in the problem to the blocks. Then we can do the same thing to represent our second addend, 53 hundredths. I'll use 3 small cubes to represent 3 hundredths here in the hundredths column, and 5 tenths, or 5 rods, in the tenths column. And again, I'll also represent these blocks numerically, 5 tenths and 3 hundredths. To model adding to, we can slide these blocks up to combine with the blocks at the top. And so the sum is the value of all these blocks. Okay, so let's figure out what the sum is. So I have 2 represented by 2 flats, I have 11 tenths represented by 11 rods, and then 7 hundredths because I have 7 small cubes. But since I know that 10 tenths, or 10 rods, is the same as 1, or 1 flat, I can trade these 10 tenths for 1, or 1 flat. Okay, now I have 3 represented by the 3 flats, and I have 1/10 and 7 hundredths. Now I can write this addition problem vertically. I can also write the addends in expanded form to show what we did with the base 10 blocks. So 2 64 hundredths in expanded form is 2 plus 6 tenths plus 4 hundredths. And 53 hundredths can be written as 0 plus 5 tenths plus 3 hundredths. Then I'll combine these by place value, starting with the hundredths. So I get 7 hundredths, and I'll draw an arrow to connect the number in my equation to the base 10 blocks. So here are the 7 hundredths. Then in the tenths column, 6 tenths plus 5 tenths equals 11 tenths. But remember that we made a trade of 10 tenths for 1 whole, which left us with 1/10. So we can write this as 1 and 1/10. And here's the 1/10. Finally, we have 1 plus 2 plus 0, or 3. And we can say this sum as 3 17 hundredths. Okay, so you can see how using these blocks can be a really helpful way to represent and solve decimal addition problems. Let's recap how we used the recommended strategies from the What Works Clearinghouse Practice Guide. We connected the concrete representation to the abstract in several ways. We wrote the numeric values of the blocks in each column. We wrote the numbers in expanded form to connect to the blocks and build place value understanding. And we used arrows in different colors to connect the base 10 blocks to the numeric problem and the sum. Now you're ready to apply these strategies for connecting representations to help your students build understanding of decimals as well as other mathematics topics. So get out some base 10 blocks, chart paper, and markers to engage students in building decimals, in regrouping and trading, making sums, and labeling the values with numbers.